All right, 6:15 at night, dinner time, drink time, blackjack time, shuttles are shut down, but you all came here to see us speak about data quality. Y'all must have some messed up data, seriously messed up data. We really appreciate your coming. I know it's tough to be here right now, so thanks so much. My name is Brian Ross, and I'm the Senior Software Development Manager for AWS Glue. And we're going to talk today about data quality, which was launched this morning in Swami's keynote. If you've been to any talk here at reInvent this year, or last year, or at any summit in between, you've heard about modern data platforms. Every one of our customers are trying to modernize their data platforms, modernize their data warehouses, their operational data stores. They're building data lakes or trying to make sense of their data lakes. They're now starting to think about data as a product. Forward-looking customers are now building multiple data lakes within their organizations and trying to figure out how to create producer-consumer interaction and with data mesh architectures. But this is hard stuff. If you've done it, you know it's difficult. How do they build these modern data platforms? Well, the number one place to do it on AWS is AWS Glue. AWS Glue is a serverless, scalable, modern, cloud-native data integration service. And to date, we've allowed more than 100,000 customers to build a modern data platform on the cloud. Our serverless architecture allows you to not worry about compute, how it's produced, how much you need, when to shut it down. We really focus analytics on utility computing, where you pay only for what you use. Our customers trust us to run mission-critical data integration tasks, which is why over 100 million jobs are run every month on AWS Glue today. AWS Glue is enterprise-tested, battle-hardened for customer workloads with 99.95% API reliability. And on top of all that, it's 100% open source compliant. The code that you write or that gets generated for you on AWS Glue can run on any platform. So you're not locked in to anything. So with that, how do customers build modern data platforms on AWS Glue? Well, it obviously all starts with your data sources. And our customers have a lot of data in a lot of places. Relational databases, NoSQL databases, lots of files in various formats all over the place. Data at rest, streaming data in motion. Sometimes this data has a very rigid, fixed schema. And sometimes the schema is constantly evolving. Sometimes the schema is not even known up front. And sometimes the data is resident in AWS, and sometimes it's in on-premise or in another cloud provider. So with all these options, right, and this whole plethora of data disparate all over the place, the first thing, of course, you do is you need to connect to it. And AWS Glue provides you with over 100 native and marketplace connectors to connect to just about anything, just about any database, any SaaS provider, anything you can think of, streaming, Kafka, Kinesis, whatever you need. And you can use our crawlers to go over that data and discover metadata about it, infer the schema from it. We can profile the data, find statistics about it, and put all of this in the AWS Glue data catalog. The catalog is a metastore that allows you to have one place in AWS to manage all of your data sets, and for all other analytics services to go find them, to know how to connect to them, and to know how to write optimized queries against them. And once it's in the catalog, you need to transform it. You need to clean it to get it ready for consumption. And Glue allows you to do that regardless of your level of expertise and the preference of how you want to work. If you're an ETL developer, perhaps you're coming from one of the old guard ETL tools that have been around for about a quarter of a century and define this space. We have AWS Glue Studio, which allows you to visually build your pipelines. Drag and drop with pre-canned transformations that you can use to very quickly do it and run it still at scale. If you're an engineer and you prefer to work with code, you can run Python or Spark using our serverless notebooks, which allow you easy access to our serverless engine and go away as soon as you're finished using them. And if you're a business user who wants to get in on this action and be able to go and clean your data, prepare it maybe for machine learning or for reporting, and you don't want to write code, and you don't even want to deal with messy pipelines, you can use Glue Data Brew, which provides a spreadsheet-like interface that allows you to work with your data and transform by example. And will record what you do as a recipe on a small section of your data, and then apply it at scale to a larger section of your data. And all of this works because of our underlying serverless data integration engine, which allows you to run workloads at scale in Python, in Apache Spark, and as of this past Monday morning, on Ray. So no matter what kind of workload you have, small data, medium-sized data, big data, evolving schemas, regardless of what it is, it'll run on AWS Glue that you can use to build your data lakes, build your data warehouses, all your modern data platform needs. But there's a problem. Regardless of how much money and time you spend building these modern data platforms, the quality of your analytics is only as good as the quality of your data. If you have poor data, you will still make decisions driven from that data. They'll just be the wrong ones. Gartner did an estimate last year and found that on average, companies lose about $12 million a year due to poor decision making based on bad data. Here's a specific use case. Electronic health records drove massive efficiency over the past 15 years in the healthcare industry. There was an EHR clinical research project, though, that took a look at the quality of data in EHR systems. And they found that all over the place, there was missing data, incorrectly entered data, and sometimes that really mattered. In a study they did, they examined 79,000 emergency room visits of children under 5 years old. And they found that not only in a lot of cases were their weights incorrectly entered, but in 34% of those cases, it resulted in incorrect dosage of medication being administered. So this stuff is serious. And think about your own businesses. And what's the cost? What are the consequences of making poor decisions because of poor quality data? Good, so now that we know that it's important, how do we solve it? So today, you have quite a few options, and you might be familiar with them. So firstly, there are the old guard tools. You might have had a tool installed in your on-premise environment for quite a while. These tools obviously require you to provision infrastructure, install them, and manage them. They tend to be very focused on relational databases, the databases that you've used before, the databases of your parents' generation, right? Your second option is open source frameworks, and there are quite a few of them out there. Amazon has one called DQ. There's Great Expectations. There are a few others. And these do a fairly good job, as long as you're comfortable with code, and everyone who cares about data quality in your organization is comfortable writing or reading code. And, of course, you have to manage them in the infrastructure and upgrade them and all those sorts of things. And there are also niche solutions, usually focused on one type of data, one persona, or a particular industry vertical. So, what are the problems with tools like these? Well, first of all, it's all about infrastructure. You've got to provision the hardware or instances, EC2 instances or something like that, on the cloud. And you've got to install it, and you've got to configure it. You've got to deal with how much to provision. What's the peak, right? How much compute do I actually need to run at scale? And you have to analyze that ahead of time so that you're aware so your jobs don't fail. Of course, you're going to have to patch those things, right? Deal with security questions, et cetera. And if you've chosen off-the-shelf solution, you're going to have to pay expensive licensing fees. And if you're here at reInvent, it's probably in part because you don't like paying expensive licensing fees, and you like the utility compute model that AWS offers. But then the real work starts, because the real work is trying to figure out what quality looks like for your organization. And that really means going through data set by data set, column by column. What is the min value? What is the max value? What is the domain of allowable values? What's supposed to be null? What's a number? What's a string? What does completeness look like? What does referential integrity look like? It's a giant analysis project to figure out what data looks like. And this is without the technology. This is just humans doing grunt work before you can even use a tool to implement rules based on the output of that project. And then, once you've done that, implement it, got it running, already a lot of work here, you have to deal with scalability and performance issues. What happens when the data size increases? You've got to scale up. How are you going to scale up? Right? And even if you scale up, does the technology solution you've chosen or implemented, does it know how to even make use of all that infrastructure, of all that compute that you've provisioned, or do you end up provisioning 50 instances and all your data actually runs through one and you just pay for the other 49 just for fun, right? So fine. And then, of course, when your data quality is not running, because your data isn't necessarily changing all the time, you're paying for compute that sits idle. Also, there's a good chance that whatever you've implemented or whatever you've chosen doesn't support multiple personas. So there's a data steward persona, there's an engineer persona. It depends on the size of your organization. But for most organizations, there are a lot of people who care about the quality of data. And not all those folks know Apache Spark or Python or even can read JSON or YAML or things like that, right? But if you take a tool that's designed for business users, it may not be flexible enough for what engineers need. And then lastly, most of these tools, they either focus on a data store, but not the ability to embed it into a pipeline. And this is important because while we speak to customers, what we find is that even the customers who are forward-thinking enough to do something important with data quality in their organizations, even those folks, they're almost always doing it reactively. They wait until the data is already in their lake or their warehouse. Then they run something, and then they find out that they're in big trouble. And then all of a sudden, of course, all the alarm bells go off, and they have to try to figure out how to do it, how to fix it at the source and rerun the batches, and sort of doing that overnight before the business opens in the morning or something like that. They don't focus on proactive quality management, preventing that bad quality data from getting into their analytics stores in the first place. Okay, so we have a lot of problems. It's really hard to build and operationalize data quality management. And that's why we're really excited to announce the launch of AWS Glue Data Quality, available today in preview in select regions. AWS Glue Data Quality is designed to address all the problems we spoke about that prevent you from successfully managing your data quality today. And so what are the benefits? Well, first, it's Glue after all, so there is no infrastructure to maintain whatsoever. It's fully serverless. You don't worry about scalability because Glue uses that same serverless engine that we use to run over 100 million jobs a month for data integration. You get auto-scaling out of the box. You get the ability to run on dedicated instances underneath the covers or run on spare compute for less money. We've also built AWS Glue Data Quality on top of Amazon DQ, an open source library that's been used internally within Amazon to manage data quality on data lakes of over 60 petabytes. One of the challenges we spoke about is that there's a giant project required to figure out what quality looks like in your organization before you can even get started. We wanted to short-circuit that process. And so the first thing you do when you use Glue Data Quality is you hit the recommend button. And we'll just look at all of your data, we'll profile it, and we will generate all the rules for you based on the current state of your data. Now, Everyone here is probably thinking, well, the current state of my data is not very healthy to begin with, right? But that's much better than a blank sheet of paper, I can assure you. And then, of course, once you get those recommended rules, you can always tweak them, add, remove, modify them, till it matches the quality you're looking for. Make them a little bit more relaxed or a little bit more strict as you need. We have over 20 out-of-the-box rule types that we're supporting, and automatic actions that you can take, such as alerting someone that there's a quality problem as quality deteriorates, or stopping the job and preventing bad quality data from getting into your data lake or data warehouse in the first place, so that you can deal with it before your business users are impacted. One of the things that, and we'll talk a little bit more about this in a bit when Shiv comes up, is we found that when people implement data quality solutions, if they do it in code, as I mentioned, the business users can't read it, can't write it. It's also really hard to visualize. It's hard to move between accounts. Most of you probably have a promotion cycle where you work in one account for like your development and then move to a test or a stage or a production account. And if the rules are just in code, it's often hard to do that and to manage it. And so we wanted to be able to express those rules in a way where they're easy to read and write, they're easy to visualize, they can be run on AWS Glue as a scalable platform, but also that we could also compile to other compute platforms. So we could potentially take the same set of rules and take them to your data lake, run them inside your data warehouse, run them inside your operational data store without you having to do anything. And we looked around for a way of expressing rules that would allow us to do that. And we didn't find one. So we had to create one. So we created DQDL, Data Quality Definition Language, a very easy to write and easy to read language for declaratively expressing these rules. And don't worry, if you don't like that, we support SQL, of course. Okay, great. So what else? Data quality at rest and data quality in transit. Glue today supports batch as well as real-time streaming data pipelines, and Glue data quality is no different. And we focus on multiple personas. If you're interested in reactive data quality at the data set level, if you're a data steward, for example, you can go right to the Glue data catalog, look at a data set, and see its data quality or evaluate quality right there. No code required. But if you're a data engineer who wants to be proactive, as you're building your pipelines, either visually in Glue Studio or in code, you can insert data quality evaluations at any step that you'd like and achieve the same thing, but with, of course, more flexibility, because then you can write code to not only do transformations before it and after it, but also do additional things that you'd like maybe quarantine data and write it to S3, put it wherever you need, because perhaps maybe you have your own dashboards that you want to use and your own tool set to monitor these things. So you can essentially do anything you want with it at that point once you're doing it as part of your pipelines. So where does this fit in your architecture? Well, this slide you saw a couple of minutes ago without the green boxes. One of the things we've heard from customers like you is that you don't want to be forced to leave the job you're in the middle of doing to do another one and then come back. So we've put data quality in the places you need it. So you can go to the data catalog, search for your database, search for your table, and then say, evaluate data quality. See my results. Look, see how they've changed over time. Or, in the middle of your Glue Studio job, you can go and add a node to your transform called evaluate data quality, and then you will be able to operate right there. We want to make sure that regardless of your comfort level, whether it's code or visual, whether you're more of a business-aligned user or a technology-aligned user, that you would be able to be successful using Glue data quality. So now I want to show you a little bit more details about how Glue data quality works, and then, of course, show you a nice demo. But to do that, I'm going to hand it over to Shiv Narayanan, who is the product manager for Glue data quality.
Thanks, Brian. Hope you're able to hear me. Hello, folks. My name is Shiv Narayanan, and I'm a product manager for AWS Glue Data Quality. Brian talked about how important data quality is. And I think you guys showing up at about 7 o'clock tells it all the more, right, as to how important data quality is. It actually is even more, right? So you saw about the features, some of the benefits of that. So now it's time for us to kind of go a little bit more deeper into these functionality. So first, how does it work? Brian talked about the fact that we've actually put data quality feature at your arm's length, right? Wherever you are, you can actually start accessing data quality. So the first place is the data catalog. So we know that hundreds of thousands of customers have actually built data lakes. And these customers do want to manage data quality of this data set that has already been ingested. So a data steward can simply go to Glue Data Catalog, select a data set, and click on a recommend button. So what we do when you click that recommend button is we profile or analyze your data, gather statistics, advanced statistics, and create data quality rules for you that you can actually start to review. You can then start to tweak these by modifying some of them, change thresholds, add new data quality rules, and then you're now ready to go, right? This is such an important step because a lot of times we've heard from customers that just getting to this point is the most hardest job. The next step is now you're ready to run these rules, right, against your data set. So when you're running it, you can associate actions at that point in time. So some of the actions include writing to CloudWatch, right, so that you can set up alerts, and we're going to show you how you can actually do that. Another thing is to write to S3. And finally, you get to see the results. So once the evaluation is completed, you get a data quality score. The score will tell you how good the data quality is. Higher the score, the better, right? You can make confident business decisions. Lower means you can actually now dive deeper and then look at specifically what went wrong, and then you can start to work with your source system owners. So is this enough? Clearly, what we heard from our customers is this is not enough, right? And this is what Brian talked about, the proactive versus the reactive data quality. So this is the most of reactive data quality, right? So now, if you want to go and implement a proactive data quality, which means you want to prevent bad data from entering into your data lakes, you simply go to Glue Studio. If you're a Glue Studio user, there's a transform that's made available for you now. It's called Evaluate Data Quality. You drag that transform, you insert that in the middle of your pipeline, you configure data quality rules, and you start to execute them, and you get the same benefits of associating actions such as publishing to CloudWatch, writing to S3, stopping the job in the middle, and then you get the results, including data quality scores. So we talked about how this works. You're actually going to see this much more in detail in a demo. Let's talk about the technology that powers this, right, in a little bit more detail. So when we started to work on this problem, we thought to ourselves, what does this engine have to look like, right? So there were really three key things that this engine that powers data quality needs to accomplish. One is scale. It needs to be really working on data sets because, like you saw some very impressive statistics, our customers do have really large data sets. The second one is it has to be proven, right? It needs to work and has to be proven elsewhere. And the third thing is we know that you guys love openness. You do not want to be locked into a particular technology. So these were the three key tenets that we had to focus on. And it turned out that DQ is a perfect solution for accomplishing these three. Now, how many of you know DQ? Good. That's actually a good number. So DQ, for those who don't know, is an Amazon developed library for measuring and monitoring data quality that we open sourced. Now, our plan is actually to own this, take it forward, contribute back all our innovations, and maintain this, right? So that's something that we are actually committing to. So internally, we use this to measure and monitor data quality, and it has been proven in our data lakes with over 60 petabytes, right? So if it works at 60 petabyte scale, hopefully it should work there in your environments too, right? The second one is the openness, right? So it is actually open source already. We are packaging this for you, so it should allow you to build data quality rules and then take it anywhere. Hopefully you don't take it anywhere, but if you must, you can still do that. And a lot of customers do use it already, and they have asked us for a managed option. So DQ was a perfect marriage to use for our data quality solution. All right, so Brian talked about the next problem, right, which is how do you express this data quality rules? It's such a big problem that we kind of started thinking together during our design phases. We thought to ourselves, like, how do you like kind of create these rules? So it turns out that there are really 4 problems with expressing data quality rules. And it's really complex, right? The first one is developers have to write a lot of code. Either they'll write it in Python, they'll write it in Scala to manage data quality. It's just a complicated business. And even if you write it, right, the consumers of this, which are the business users, simply don't understand that. I mean, like, you cannot train your business users, I guess, on Scala or Python. It's not a great idea. And even if, let's say, you did that, migrating these rules from one environment to another environment is hard. So let's say we just take a step back. Let's say, for example, the coding is not the right option. The other option is actually to use wizard-based, right? Like we thought about, can we actually build a bunch of wizards and then make it available? But the problem with that is, again, you need to be able to migrate these rules from one environment to another environment, and more importantly, reusability, right? So reusing is also very hard. And other options is, like, there's a ton of proprietary languages, and it was not useful. So like Brian talked about, we actually went ahead and created a new language, and this is how it looks. So this is actually a screenshot from our editor, and this is what DQDL looks like. So there are really 5 things that you can notice. First thing is it's actually easy to author, right? It's not like you're going to learn something new. It is very simple and straightforward. So for example, is completeness means there's no blank values in your data, right? Standard deviation greater than a certain number means that. There is nothing crazy about it. So we went ahead and built this language. It's easy to author. It's simple to understand and visualize, even for business users, because it looks like very, very intuitive and plain, right? And then, more importantly, we wanted to add complex business rule support. So you can write if and or rules. For example, is complete of total amount and total amount standard deviation should be greater than XYZ. So you can actually write them. And it allows you to be reusable. And if you notice here, there is actually no mention of a data set. You can actually kind of start writing this right off the bat, right? Like without even actually having a data set. And eventually replace those, the column names. And there are, like, our focus is actually to make sure that this is even more reusable. But this actually creates that framework to make data quality rules more reusable across different data sets. And of course, it brings the power of SQL. So there's one rule out there that shows you like how to kind of run SQL in case if you don't like us, our DQDL, there's always, you can write SQL all you want, right? So we all want to see this in action now rather than talking too much about it, right? I think, so let's go through a demo, all right?
Welcome to AWS Glue Data Quality demo. ABC Taxi is a fictional ride-sharing company. The finance department is responsible for making key decisions based on a dataset called daily trips data. This dataset has data about the time when a taxi picked up passengers, number of passengers traveled, and the charges for the ride, including surcharges, tax, and tips. Recently, the team has been making incorrect decisions, and they found some abnormalities with the data. For example, 208 passengers traveled in a single taxi ride. They started to lose confidence with this data set and have asked the data engineering team, who is responsible for managing this data set, to help. They want to be notified when quality issues occur. Let's look at how AWS Glue Data Quality helps the data engineer get started quickly to measure and monitor data quality. The data engineer goes to AWS Glue Data Catalog, selects the database and the specific data set. The data engineer then clicks on the Data Quality tab. The data engineer now has an option to create the rules from scratch. However, he chooses to get AWS Glue to do the hard work of analyzing the data and recommending the data quality rules. He clicks the Recommend Rule Set button, provides a rule set name, selects a IAM role, and looks at additional configurations. They look good. He then clicks Recommend Rule Set. Glue creates a recommendation task by spinning up a dedicated environment in seconds to analyze the data, calculate advanced statistics without any infrastructure management. Without the serverless architecture, the data engineer will have to set up this infrastructure and the software to perform all these tasks. The recommendation task is completed. Glue's distributed processing capabilities allowed the user to generate recommendations on a dataset with over 22 million records and 14 columns in under 2 minutes with 5 worker nodes. The data engineer now clicks the Daily Data Quality Checks rule set to review the recommendation. A rule set is a set of data quality rules. For this recommendation run, Glue has generated 40 data quality rules. Glue generates data quality rules based on values in the dataset, reducing the need to manually creating these rules. Notice that Glue generates a variety of data quality checks that check for completeness and accuracy. Also notice that Glue has recommended higher thresholds for passenger counts and total amounts. After reviewing these rules with the finance team, the data engineer decides to adjust the thresholds and add new checks. The data engineer clicks the Edit button and in the Data Quality Editor reduces the passenger counts thresholds from 208 to 8. Then he adjusts the total amount to be under $500. The data engineer now browses through the out-of-box rule types and selects Custom SQL Rule Type to implement a rule that ensures that the sum of trip charges, taxes, tolls, and tips match up to the total amount that's calculated. The data engineer finalizes the rule set and clicks Update Rule Set so that the changes are reflected. He now selects the rule set and clicks Evaluate Rule Set. He leaves the default option to publish metrics to CloudWatch. He then provides a IAM role that has access to the dataset and also has the right permissions to run the jobs. Provides an S3 location where the data quality results can be stored, and then clicks Evaluate Rule Set. Data quality evaluation is started. AWS Glue will now evaluate all the data quality rules which is part of the rule set against the entire data set. The data quality evaluation is completed, and notice that 2 data quality rules have failed. The business users can now browse to the data catalog and review these results. The business users can now quickly see that the data quality score is 95%. She can also search for failed rules and look at what rules failed. Now that the business user knows what the issues are, she can contact the source system owners to fix this issue. In the meantime, the data engineer has scheduled the data quality execution by calling data quality APIs via step functions. As next steps, the data engineer will go to CloudWatch to set up notifications so that the user will be alerted every time these data quality rules fail. The data engineer navigates to CloudWatch and creates an alarm. He clicks the Select Metric to select the existing metric. Remember that we have already executed the job once with the option to publish to CloudWatch. You can see in CloudWatch that we have the number of rules passed metric and the number of rules failed metric for the specific rule set that he executed. He selects the number of rules failed metric. He wants to trigger the alarm even when one quality rule fails during the rule evaluation. He clicks Next. He now configures an SNS topic to notify when the alarm triggers. This will send email notifications to business users when quality rules fail. He now provides a name for the alarm and finally creates the alarm. Let's go back to AWS Glue Data Catalog and looks at what happens when the data quality rules fail again. As you can see, the data quality rule evaluation has started for the second time. Notice that the data quality rules has failed again. Let's go and look at CloudWatch, and you can see now that the taxi trip alarm has been triggered and an email notification has been generated to the business users. Now, the business users know that the issues still persist and works with the source system owners to address the data quality issues. The business owners, source system teams, and the data engineers have been collaborating over the past few days to fix all the issues, and finally, the data quality score has improved. The execution results and trends can be easily accessed outside the AWS Glue Data Catalog, as these metrics are written to Amazon S3. The data engineer can easily query these results to see the trends using Amazon Athena. With the data quality results in Amazon S3, data engineers can also build dashboards to visualize the data, to look at the data quality scores over time, and also to visualize the trend data using Amazon QuickSight. Business users are now happy with high quality data and have started to use this dataset for multiple use cases. There is now a new business requirement to aggregate the TRIPS data. The business users want to prevent bad data from entering their data platform by checking the quality of the data prior to aggregating. With AWS Glue Data Quality, data engineers can easily and proactively validate data quality before they start to process their data. Let's now see how a data engineer can set this up. The data engineer navigates to Glue Studio and clicks on View Jobs. He selects the option to get started with a blank canvas. He selects the Source tab and selects AWS Glue Data Catalog as the source. He configures the TRIPS dataset in the source node. He then clicks on Actions and selects Evaluate Data Quality node and adds it to the canvas. Here, he configures 3 critical rules to validate data quality. First, passenger counts should always be less than 8. 2. The total trip charges should be under 500. 3. The sum of taxes, tips, and trip charges should be equal to the total amount. The data engineer has reused the rules from data catalog by copying them instead of creating rules from scratch, minimizing the need for coding and testing. The data engineer wants the results to be published to CloudWatch. He also wants the job to immediately fail when bad data flows through the ETL pipeline. The data engineer now adds the aggregate transform to summarize the data. Finally, the data engineer adds an S3 target. The data engineer now moves on to the job details page to configure the name of the job. Next, the data engineer selects auto-scaling option so that the data quality rules and aggregations will only use the worker that it needs and will automatically scale up or down based on the data volumes. He has the option to enable flex execution, which uses spare capacity and is ideal for non-urgent workloads. Flex execution is cheaper by 34% compared to normal execution. In this case, he's not going to enable this option. Both Flex and autoscaling execution makes Glue Data Quality a cost-effective option to manage and monitor data quality. The data engineer clicks the Run button to start the job and goes to the Runs tab to monitor the status of the job. This job is completed successfully. The data engineer clicks the Data Quality tab to monitor the quality of data within the pipeline. As expected, no data quality issues were detected, and the pipeline has aggregated the data set and has ingested this data into the data lake. The business users now have aggregated data that will enable them to make confident business decisions. Hope you enjoyed ABC Taxi's data quality journey. Glue Data Quality offers a simple, scalable, and cost-effective solution to measure, monitor, and manage your data quality. Visit us at our webpage to learn more and to get started. Thank you.
All right, so now you know how it works. We figured you'll have questions. So let's answer a couple of frequently asked questions, right? As much as time makes it easy for, so let's just make sure that we address at least one or two questions. So first is, how many out-of-box data quality rules do we support? Not all of them are listed here, but just a few of them for you to watch. We support data quality rules across 4 data quality dimensions: consistency, that ensures that your data is consistent across different rows; completeness, which means that you're checking to make sure that there is no null values; accuracy, under here you will be able to check for column values, make sure that the means and row counts are accurate; and integrity, right, to make sure that your data agrees with what you actually want it to be. For example, there are no duplicates. There are more than 20 data quality rules. Again, like I said, not all of them are listed here, but each of these rules are really feature-packed. For example, you don't see a regular expression check because the column values data quality rule supports regular expression. So we have tried to minimize the number of data quality rules that you really have to think through so that it's easy for you to write, right? And it's easy for you to learn DQDL. And again, like I said, we support SQL. So if there's a complex business requirement that we cannot support right now, you can always write a SQL data quality check. So pricing, it's very common, right? So to understand pricing, first let's go through the rows, right? So this first row, which talks about data quality recommendations. So we charge you for 2 things. We charge you for getting recommendations, and then we charge you for executing your data quality rules. So pretty much the compute. And on the top, the headers, you see Glue Data Catalog and Glue ETL. That's basically how you access, right? So for both getting recommendations or for evaluating data quality, you will spend 44 cents per DPU per hour. And this is, you need a minimum of 2 workers. And if you're implementing this in your ETL pipeline, you have 44 cents again per DPU per hour. It's actually the same as catalog, but there's the option to enable Flex, which is not available in data catalog yet, but in the ETL pipelines, you certainly can enable this. So what Flex does is it allows you to use reserve capacity to execute Glue jobs. So this is ideal for your non-SLA sensitive data sets that it's okay to run your data quality checks after maybe, like a couple of hours, or maybe in the night, you just wanted to make sure that you're running it. So those are ideal for Flex because it uses reserve capacity and it's 34% cheaper, right? So what does it really mean, right? So what it really means is, for example, the first line item on the bottom shows you in order to get a recommendation for a job that runs for 5 minutes, for 2 DPUs, you're going to pay 7 cents, right? And for evaluating the quality of the data set, and let's assume that it ran for 10 minutes with 4 worker nodes, then that'll be 29 cents. And the same workload on Flex execution will cost you about 19 cents. That's 34% cheaper. So what's the summary of this, right? So there are really two key takeaways. One is that Glue is probably one of the very few solutions that offers you a pay-as-you-go, or probably the only solution that offers you a pay-as-you-go model, and pay by priority. What this means is that not everything is created equal. You can actually take your workloads, take your data quality rules, split it up, and then use the right type of execution and pay and make it still cost effective. So this is all great. What are our customers saying, right? One of the most important things at AWS is working backward, right? And it's so important to work backwards from our customers to build anything meaningful, not look at anybody else, but just simply look at your customers, listen to them. And we have been really fortunate to have a lot of customers help us. For example, Wire told us that, after being part of the pilot customer, told us that they were able to save about 1,500 hours. United was very excited that they can also save countless hours because we are recommending data quality rules. And RX was super excited because now they have managed a DQ solution. But there's one special customer who's actually come here, who's going to actually share his vision and how it aligns with Glue. I want to welcome Sudeep, VP, Chief Data and Information Architect from Travelers. Sudeep.
Thanks. Good evening, everyone. First of all, I know I'm standing between you and dinner, so it'll absolutely make it more engaging. My name is Sudeep Joseph. I lead architecture for data analytics for Travelers. Any Travelers customers in the room? Awesome. Thank you for the business, and I'm sure that you are well protected under the umbrella. So some fun facts, a little bit of an interesting fact about Travelers. Some of you might not know that 160 years ago, Travelers was the company who introduced the concept of accident insurance, which turned into auto insurance in the United States. So very proud about that. And of course, I'll just flip the slides. Awesome. And of course, we are hiring. So definitely, let us please visit our career site if you're interested in any of the opportunities. We are hiring for engineers, architects, data scientists, all different roles. Now let me get to the topic. So data quality. Now one of the key questions is, traditionally we have thought about data quality as more of running historical trends on warehousing data, maybe monthly once, twice, to understand if there are any anomalies or any issues within the data. And oftentimes, by the time we identify the issue, probably might have lost the opportunity, right? So, but what's happening right now is, most of you know that in our businesses, over the past 3 to 4 years, we have significantly increased the number of predictive models and automated decisions in the workflow. So in Travelers, it's no different than any other company. We use significant number of predictive modeling capabilities, right from simple models to highly complex machine learning and deep learning models, from geospatial to imagery to different capabilities. So how do we keep track of all of these things? And as we started discussing about this problem, we soon recognized that knowing the data and keeping track of the data and the ingredients that go into these decisions is exactly the key important thing, right? Decisions otherwise can automatically happen, but we might not recognize that it was not really the right decision that we had to have. So we thought about an approach around really taking a look at the problem, and of course we knew that it had to be different from what we have seen in the past. So what we first thought is, what is the framework that we need to think about when we think about data quality? So I know Brian mentioned earlier, and Shiv also mentioned about the proactive and reactive. We thought about it similarly in a 3-step approach: preventive, proactive, and reactive. Let me take a look at what exactly each one of them means, right? Preventive, of course, is as the data enters into the system, whether it's through the user interface, whether it's through service interfaces from where we collect the data, how can we ensure that we are checking the quality of the data right at the point? Because oftentimes, We might be pricing our policy. We might be determining the complexity of a claim. We might be determining various factors based on the data that we collect. And if we don't validate the quality of the data, we might not make the right efficient decisions that our customers want us to do. So we definitely recognize that preventive is absolutely something we have to really do about it. The next thing is proactive. We can try our best to be preventive, but as we know, practically, everything is, sometimes it's not possible fully. So what's proactive? How do we shift to as the data comes through, whether it's through real time, whether it's through streaming, whether it's through batch, can we monitor the quality within the process and not outside of the process? Because outside of the process really takes down the process, it creates delays, it creates quality, further issues. So the proactive approach is, how do we embed data quality within the process that we do? Like Shiv was mentioning, the ETL example from Glue is a classic example of that. And reactive is definitely the classic example, how we have done it always in the past, running against our historical data. And that would still continue to happen because we always need to look at historical trends to really identify if there are real anomalies that happens within the data that might not be happening in a particular period of time, but rather an expanded period of time. So then further then how we thought, okay, great. If we were to have a solution, how would that look like? The ideal simplistic picture, if you look at this, is the set of boxes at the top is the workflow, right? How we collect the data, how we process the data, how we store the data, the results. Can we have a solution that can actually cater to all of these? And why is this important? Because we do not have time and effort. The magnitude of problems that we are actually solving and the magnitude of data that we are ingesting, we really don't have time to manage different environments. And the most important thing is we get similar data from multiple sources. So can we reuse the logic? Can we reuse the rules? And reusability becomes a critical factor just for productivity and efficiency. So our ideal scenario would have been an amazing tool or a technology that can actually solve the entire spectrum of our use case. Then the question comes in, okay, that's awesome. What would be some of the characteristics of that tool, right, if that exists? And that would be something similar. Maybe most of the boxes are out here might be familiar from the last 45 minutes of the presentation. Based on our own practical experience, doing various custom solutions, various homegrown build, scalability is a big issue. Because especially with the volume of data that we are consuming, petabytes of data from various sources like imageries and aerial imageries and other data, it's very difficult for us to keep track of without a scalable infrastructure. So that's number one thing. Like I mentioned earlier, embedded within the process. We definitely want the quality to be embedded in the process and not run outside of the process just because of the performance and the efficiency that we need. Declarative way of defining the quality rules. We talked a lot about DQDL. A framework like a DQDL is quite important. Our data quality people are primarily the people who mostly knows the business, or the business people who knows exactly what the range of a particular value of a field should be, not necessarily always our engineers. But how do we bridge the gap between our engineers? But how do we create a framework that our engineers can take and they can seamlessly deploy? They don't have to actually work with a dependency from a business user. So a framework that can actually do the declaration in a useful and an easy to understand manner from a business customer, but at the same time, that's embeddable with an engineering process. So that is a critical quality that we always look for. Of course, like I said, it has to support both the technical and business users. Because ultimately, like I said, data quality, we started actually even internally stopped calling it as data quality. We started calling it as business quality monitoring. Because ultimately, data is just the business. So how do we get the business customers more engaged? They're more interested in the data right now. They want to know the expectations so they know the results of the predictive models and the decisions that are happening downstream or within the process is exactly happening out the way they want it. And of course, last but not the least, the AI ML driven. Of course, automation, anomaly detection, most of these things are not always rule driven and authorable. So predictive models like AI or ML models are important as this capability evolves. Like you said, like most of you might have seen from the demo, it's very exciting to see that AWS Glue Data Quality is covering a significant amount of the capabilities that customers like us are looking for, and absolutely looking forward for the final GA product for Glue Data Quality. Thank you, everyone.
All right, thank you very much, Sudeep. So the vision of such customers, right, is what helps us drive innovation. We're so fortunate to be working with travelers, piloting and sharing our vision with customers, not only with travelers, but also many other customers. So we really thank you so much. And there's a lot of things that we talked about today. You will also find a lot of content if you visit AWS Glue webpage. But there's one action that I want you to take. Of course, get your beer. There's no question about it. But go start clicking on the data quality, like access data quality. Click on the data quality tab and click on recommend rule set. Get the recommendations. Try us out. We can't wait to hear from you. And we're super excited about this product. This is just a journey of something that's huge for us. So we're really looking forward to hearing from you. Thank you so much. And enjoy your night.